In 9.7, we'll learn about complex numbers and really how to combine complex numbers together. So first of all, we let I be defined as the square root of -1 because it turns out, if you look at the equation x squared equals -1, what number squared gives you something negative? That's going to be not a real number. So what we're going to do is we just define a solution to this equation to be, just call it the square root of -1. We'll use I for an abbreviation so I don't have to write all of these symbols. I stands for imaginary. So if I is the square root of -1, then that means that I squared would be equal to -1. So we're going to use those ideas and then think about this whole new number system now. Okay, using this definition of I, let's simplify. What is the square root of -36? So here's how I want you to think about it. When you have a negative number underneath the square root symbol, kind of think of it like, that's like -1 times the number. So then the square root of -1 is I. And then we can just kind of evaluate the rest of it, square root of 36. So this will be 6. And I like to write the number part first. So that'll be 6I. So a shortcut for writing this is whenever you see a negative symbol, the negative sign inside the radical, it'll come outside of the radical as an I. It'll pop up out front here. All right, so similarly here, the square root of -24, you can think of this as I times the square root of 24. And the square root of 24, that's something that we can simplify. I know that there's some perfect squares inside here that I could pull out. In particular, 24 could be written as, let's say, that is 4 times 6. And 4 is 2 times 2, 6 is 2 times 3. So a pair of 2's can come out, but I'm going to be left with 1 factor of 2 and 1 factor of 3 left inside the radical symbol. So this will be 2 on the outside, I on the outside, square root of 2 times 3, or 6 left on the inside. So again, we already know how to do that, how to simplify the square root of 24. The new thing here is if there's a negative underneath the radical symbol, it comes out as an I. All right, same thing here. The square root of -5, that's like the square root of -1, which is I, and then the square root of 5, which I cannot simplify. So again, if there's a negative inside the radical symbol, it comes out as an I. All right. Now, when we have complex numbers, a complex number can be written as A plus BI, where A and B are real numbers. A is called like the real part, B is called the imaginary part. What I want you to think of is sort of like, instead of having an x-axis and a y-axis, we kind of have the real axis and the imaginary axis. So, you know, if you had like 2 along the x-axis and 3 up, so this is 2, 3. This point here in the plane, that would have coordinates 2, 3. And we can write that as 2 plus 3i, okay? So if you want to think of the complex numbers as being sort of like a pair, a coordinate pair in the xy plane, it's very similar. So the complex number system is like a 2-dimensional number system here, where points can be represented by their real part and their imaginary part. Okay, so therefore, A, the part without the I, is the real part, and then B, which is the coefficient of I, is called the imaginary part. So now, imagine any number along the real axis here that's just like, let's say the number 1, 2, 3, 4 here. The number -4, that's just going to be a real number because it doesn't have, or its imaginary part is 0. You don't see that imaginary part. So when B is 0, A plus BI is just a real number. And then if A is 0, say the number 1, 2, 3, 4. negative 4 here along the imaginary axis, then that looks like 0 plus bi. So bi is a pure imaginary number. It doesn't have a real part. So any complex number, you can kind of split it up into its real and imaginary parts. Let's do that for these examples. Let's identify the real part and the imaginary parts of these numbers. So this is the number 4 minus 2i. The real part is 4, and the imaginary part is the coefficient of I here, negative 2. Alright, this number is a fraction. I could actually split this up because it's hard to say, like, it's not that 5 is real, the real part, and 2 is the imaginary part, because this whole thing is over 3. So really you can split this up as like 5/3 plus 2/3 I. So then in this way, the real part is 5/3 and the imaginary part is 2/3. Okay? And this is, we do this a lot when we have like a fraction like this. You can split up the fraction. Alright, think of the number 7 as like 7 plus 0i. This is just a real number. The real part is 7. The imaginary part is just 0. And the number 3i, this is a purely imaginary number. So you can think of it as 0 plus 3i. So that the real part is 0 and the imaginary part is 3.